One interpretation of the definite integral is that it tells us the signed area of between the curve and the x-axis between two values. So for example, here we're looking at the signed area of this region. The curve is x squared minus 9, and we are looking from -4 to 5. You can see that the area below the curve that I've colored in purple, this is going to be negative, and the stuff that's colored in light blue is going to be positive. So the signed area or the net area is going to be a combination of those two. This is what the integral gives us. So we don't really have to do a lot of extra work to get this signed area. We can just integrate this. So we're going to go ahead, I'm going to integrate it, and then evaluate by plugging in 5 and then plugging in -4 and subtracting. Get the work done out here. You're welcome to look it over. So I get -18. So it looks like there's a little bit more negative area than positive area. Suppose instead that we want the total area or the absolute area. So what is going on if we don't count that as negative area and instead count it as positive area? So now it's going to look like this. Everything's positive. I want this total area. Well, to do that, I'm going to use an absolute value integral. But the only way to do this is to divide it into negative and positive parts and make anything negative positive. So the first thing to do is figure out where this is negative and where it is positive. I'm going to set it equal to 0 and find out where it's 0. Then I'll use a number line to find each place where it's negative and positive. So I can see that it is 0 at -3 and 3. Below -3, if I plug in, say, -4, I get a positive value. If I plug in 0, I get a negative value. Then if I plug in +4, I get a positive value. So we already know from the picture where the negative region is, but this is how you would do it if you didn't know and you didn't have the picture. So that means that I need to divide my integral into 3 pieces. I'm going to go from -4 to -3. And then the next piece from -3 to +3, I'm going to switch the sign. That part would be negative, but that absolute value symbol is going to make it positive. So that's why the sign switches. Then from 3 to 5, it is just positive again. Again, after that, I just evaluate the integral like normal. Now, it's a little tedious because I have to do 3 different pieces, but it is completely doable, right? So I evaluate the integral and I integrate each piece, and then I have to evaluate each of them at the right bounds. The trickiest part of this is really just keeping track of what's negative and what's positive as you go through. I've written all the work out here so you guys can see it all. And I finally get to the end and I get 54. So you're welcome to pause and take a look at all of this work, but I've got this set up there for you.